Hey guys, did you figure out what was special about problem 2 last time? Well, if you didn't, we're going to work it out and let's find out the answer. So what we're trying to do here is we're trying to find x of L, x of C, the impedance, the phase angle, all that stuff. So we'll start right here with x of L. Okay, so x of L equals 2 pi FL. Right? Our frequency is 500 hertz, 16 millihenries, right, and 2 pi. So 2 pi times 500 hertz. I'm not going to show my units. You know the units. L is 16 millihenries. Milli is 10 to the minus 3. Let's do that right here. So we got 2 times pi times 500. Oops. I'm in some kind of mode here. Let's do it again. 2 times pi times 500 times 16 exponent negative 3 is 50.26 ohms. 50.26 ohms. That puts that in the ballpark of this resistor, which I forgot to write, which is 50 ohms. So they're all on the same scale. In other words, what's going on here is this is not 50 ohms, this is not a million ohms. They're about the same. But that's not what's special about it. Let's do x of c. X of c is 1 over 2 pi fc. So that's 1 over 2 pi, f is still 500. And c is 6.3 microfarads. 6.3 micros 10 to the minus 6. Okay? So we'll find the bottom first and then divide it into 1. So 2 times pi times 500 times 6.3 exponent negative 6 is that number. Now reciprocal. 1 divided by answer. And I got 50.52. Huh. So we're going to call this guy 50.3. Or we're going to call this guy 50.5. And look at the impedance formula. Impedance formula is Z equals R squared plus x of L minus x of C quantity squared square root. So this guy, x of L, is 50.3. This guy is 50.5. They're both 50. They cancel out. This is engineering. We could say that because in engineering we know that 3 equals 3, pi equals 3. If we need to, 4 equals 3. So 50.3 equals 50.5. If I made it exactly, then I'd have some crazy frequency or a bunch of decimals here that make the problem sort of impractical and weird. So the problem was generated like this. So x of L equals x of C. This is called a resonant circuit. Okay, that means that vectorially all the reactance going on in the capacitor cancels out the reactance in the inductor. And the total impedance of the circuit, since this drops out, is just R squared, which is R, which is 50 ohms. So Z equals R equals 50 ohms. So I equals E over Z. And I just gave you a generic 100 volts. All right, 50 ohms. So we have 2 amps. Okay, but the phase angle, theta equals 0. And the power factor is essentially equal to 1 because we have no reactance in the circuit to do anything. This, by the way, this is what makes a radio transmitter, radio receiver work. So because there's no reactance, which is like resistance, okay, from the capacitor, and it's canceled out by the inductor, 500 hertz flows right through the circuit. But other hertz don't. So it only resonates at 500 hertz. Okay, so we can get a formula from that. Okay, at resonance, x of L equals x of C. So if we take 2 pi FL and we set it equal to 1 over 2 pi FC, like that, we could solve this thing for F. Okay, so let's multiply both sides by F. And if I do that there, it'll cancel out here, but it squares there. Now let's leave this F alone and move everything else over. Okay, so C is going to stay put. I'm going to multiply both sides by 2 Actually, I'm sorry, I'm going to divide both sides by 2. So this 2 and that 2 actually multiply together, but on the bottom, so it's 4. Divide both sides by pi, so that gives me a pi squared. And then let's move L downstairs, like that, and this equals f squared. And square root both sides, okay? So we call this resonant frequency. That's why they put a naught, f naught, or f sub 0. Sometimes some books will call it f sub r. Square rooting, square root of 1 is 1, square root of 4 is 2, square root of pi squared is pi, and the square root of LC just stays the square root of LC. Okay? So we're going to have some problems. Look for a PDF for problems doing this and maybe designing a circuit, and we've got a lot to do on this. We're going to learn all kinds of stuff, like Q of a circuit, and kind of what Q does. If you have a transmitter, it decides whether you have a big bandwidth like this, or a narrow bandwidth like that. How much spectrum you use. Which one of these would you use for a digital signal? Would it be 1 or 2? Okay. Which one can you pack more on a tuner, on a radio? Beep, 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 or something like that, which has audio and video. Think about that. That's it. Bye.